Today I'm presenting our study on password reuse at the University of Chicago. And yeah, before we dive deeper into it, I'd like to introduce myself. Since October 2023, I'm a tenure-track faculty at CISPA in Germany, and my group is working on human-centered security, and we have a rather strong focus on user authentication and usable online privacy. What is this CISPA? CISPA is a federal-funded research institution. We focus on cybersecurity and AI, and in comparison to a normal university that you might know, we focus more on research and less on teaching. And we are growing quite fast, to be honest. We are running out of space, so we are getting a new building. However, this might take a couple more years to be finished, but Per and I are already started planning PasswordsCon in 2029, right? And looking forward to see all of you there. And as you might know, research is oftentimes a group effort. The stuff we do would not have been possible without those amazing people, and I'm very grateful to have their help and support on a daily basis. If you want to talk to them, Anna is here sitting in the audience, and we are also constantly looking for new members. So if you see a recording of this talk online, please, if you are interested, send me an email and reach out to me. Okay, now let's start by having a first look at what the problem actually is we're going to talk about today. As you all know, passwords are everywhere. There is a study from 2017 that measured that US students have about 24 accounts and use 6 to 8 passwords for them. Obviously, this number is no longer up to date, and today it's more like 100 different accounts. And I think we can all agree on that with that many accounts, it's quite impossible to remember them all. And that's why we have, in fact, developed some coping strategies. You know, memorability is the biggest concern. And as a coping strategy, we use simple passwords that are easier to memorize, or we are forced into reusing passwords across multiple websites. And because nobody can remember 100 different unique passwords, right? And yeah, on top of this, over the last 10 years, there were more than 900 services suffering from a data breach, from a password leak, leading to over 17 billion leaked credentials. This is a very painful slide to make because I had to update it 3 times because this number increases every single day. I've taken a screenshot on Sunday, and now I was forced to update it again because the number got up again. And of course, those passwords are traded on the darknet, and because they enable a so-called password reuse attack. And yeah, before we go any deeper, I like to explain what a password reuse attack is. And as it is tradition here at PasswordsCon, if you already know all of this, there will be kittens in the right-hand corner, so please focus on them if you're bored. For all the others, let me give you a motivating example for password reuse attacks using the LinkedIn data breach, which happened in 2012. And unfortunately, LinkedIn was very sloppy with their data protection and didn't do a good job in protecting their customers' passwords. They relied on a so-called unsalted SHA-1 hash to hash the passwords, and this is considered almost as insecure as plain text. So unsurprisingly, within days after this data became public, 99% of all the SHA-1 hashes have been cracked. And this is, of course, a big problem for the users that are being burdened with an overwhelming number of accounts and that are forced into reusing their passwords because now their one and only favorite password is known to the world, to the attackers. And now imagine a second service, let's call them Ecmico. They follow best practices when it comes to password security, and they use a state-of-the-art password hashing mechanism like argon2, for example, which is over 1 million times slower to evaluate than SHA-1. But attackers are kind of smart, and what they will do to increase their odds, to increase their chances, they will match the email address of their victim with a prior data leak, in this example, LinkedIn. And then, of course, it becomes rather trivial for them, as they know how likely it is that a prior password has been reused or a slight variation of this password has been reused. And then, in the end, a single guess can often be enough to crack the otherwise hard to attack hash. And unfortunately for Ecmico, this means it doesn't matter which protection mechanism they deploy, as a single guess can already be enough. This is the summary of a password reuse attack. I hope you enjoyed the kitten. Now let's move on to the University of Chicago, where I did a PhD internship in the summer of 2017. So this is already 8 years ago. This is what the university looks like. It's quite fancy, reminds a bit of Harry Potter, right? But what is more interesting is their identity and access management system. This is a screenshot of what they are doing, and they have one very interesting requirement in place. It says that you cannot use this password that you have previously used on your account. And this kind of triggered our attention, because this is an odd requirement, and we were wondering, how is this even enforced? And it turns out that the university runs its own password history database. It's a file containing the hashes of every password that has been used at the university over the past 20 years. Of course, with additional information, and this enabled us to do the study in the first place. This enabled us to study password reuse at the University of Chicago. And for this project, we of course collaborated with UChicago's IT security and identity management team, and we decided to create a two-part study. In the first part, we measured password reuse at the university, taking advantage of this password history file. And then in the second part, we surveyed users that we identified having reused a password and asked some questions about their password behaviors and perceptions. We had a bunch of research questions in mind. We were wondering, is it sufficient to look for a matching email address, as I explained in this motivating example, or should we also match usernames? We were wondering, how long are accounts vulnerable? And out of the hundreds of data breaches that are around, is it important to cover them all, or is it good enough to just do a few of them that are very likely to be used? And more importantly, should defenders devote resources and GPUs trying to crack password hashes? And in fact, we did so for the study, and I'm very thankful for Cynosure Prime and friends. Special thanks to Sign, who is here in the audience, Sam, Paul, Robert, Michael, Royce. They all helped us cracking those hashes. And in the end, how often do attackers appear to have exploited reused passwords, and what factors make them more likely to have done so? And with those research questions in mind, we started this project. And of course, as I already said, research is always a group effort, and this group here is organized by Blaze, the founder of the so-called super group, security, usability, privacy, education, and research. And they are developing data-driven methods to help users make better security and privacy decisions. So while this project was initially started in the summer of 2017 with Miranda and me, in the end there were at least 10 people involved, including 2 from the UChicago's IT services, Blair and David, which we are very thankful for their support and cooperation. And of course, the person doing the majority of this work and helping us pushing it over the finish line was Alexandra, and she's now a very talented PhD student at the Carnegie Mellon University in Pittsburgh and doing their PhD there. And one reason why this project involved this many people, 10 people, and this many students, is the very long time frame it took us to do this measurement. In fact, Blaise spent 6 years, which is a crazy amount of time to make this happen. And you might wonder, why did this happen? Because the further we went down this rabbit hole, the more people from the university got involved. For example, the IT service that we mentioned, and what is kind of the default nowadays, the ethics or institutional review board, but also the general council, the provost office, IT leadership, the university's communication team, which are super important, administration, and of course the alumni association. So it was quite a painful and long process, but in the end, totally worth it. Now let's have a deeper look at what we actually did to make this happen. So we started with a list of usernames, round about 228,000 usernames that were all affiliated with this university. And this is quite a huge number for a university, and you might wonder why. First of all, the university runs its own hospital. Okay, this is quite a large number of users. And the second contributing factor is it included all the alumni, meaning students that have already finished with their studies, but they were still in the IT system, for example, to be able to download their transcript of records or get a copy of their certificates. So we had a huge list of usernames. And then we searched the credentials from other services that could belong to those usernames, and those credentials came from two sources. First of all, individual service breaches. We had 450 of them. This is a breach that is related to a single website and could be obtained in the past, for example, through a SQL injection attack. On top of that, there were breach compilations, 12 of them. And these are just sets of individual service breaches bundled together into one huge file. And this is what is typically mentioned when somebody talks about 1 billion passwords have been leaked on the internet. Then they are usually referring to such a breach compilation, which is a bundle of individual service breaches. Here you can see a screenshot from the paper. It is just an excerpt, but it's a massive list of breaches that in the end contributed to this. And then next we looked through the sources to find the passwords associated with the university username. And the question is, how did we do this exactly? Well, if I take my username, mgolla, then of course we use the university's email address, and this was considered to be a credential that was related to my account. But also, if we have seen mgolla@cispa.de, then we also consider this to be a relevant credential. If it is just a username, however, as soon as the username is slightly different, like in this example, mgolla99@gmail.com, we did not consider it to be an interesting credential for our research. And then to account for some predictable modifications that are typically done when you reuse a password from website A to website B, we applied some tweaking mechanisms. They were proposed in the literature. They are also based on what the password cracking community is doing. I think many people here in this room are familiar with the best 64 rule, which in fact does not contain 64 rules and now has been renamed to account for this. And then, of course, attackers are not limited to password reuse. We want to do a comparison with common passwords. And what we did, we had a look at the most common, most frequent, most occurring passwords in the LinkedIn dataset. And then we did necessary modifications to it. For example, this one password, LinkedIn1, was then adopted to the university to become UChicago1, which in the end had the same number of each character class that was in there before. And we wanted to increase our chances, and we did only guess passwords that were compliant with the password composition policy. And over the years, the university had quite a few password composition policies. You can see them here in this table. And any password that was not compliant with at least one of them was discarded and not considered to be a valid password. And of course, it's kind of odd. I haven't seen this before, but the university also has a passphrase policy in place. This is just a very long password. And then what we did, we sent those usernames and the password guesses along them with some metadata. How, for example, where does this password come from? How did we find this? To the IT department. And they did the comparison. They had access to this password history database. We did not. And they then checked this. And the IT department returned the metadata that we provided, but of course without the username and without the password, back to us. And they also added some additional information. For example, when this password was valid in the past. And then if we guessed a user's current password, IT alerted them and the account was reset and they were given a 2-week window to change their password. Otherwise, the account was locked. And users that had a password that we could guess from the past 3 years were sent a courtesy email alerting them that in the past they had been vulnerable. And I promised you that this is a 2-part study, and in the second part we also did this survey, and after notifications and password resets took place, we surveyed around about 40 users that were impacted. And this survey wasn't simply a questionnaire, no, it was also a little bit more fancy. It was customized and included details about the source of the data that allowed us to guess their password. Right? They could see which data leak contributed to their password reset. And then all this recruitment and all the compensation of the participants were carried out by the IT department. We as the researchers did never had access to the passwords. And yeah, given that this is quite a sensitive account security study, we very carefully designed this protocol. And of course, it was approved by UChicago's ethics board. We were in contact with the IT department all the time. They were the only ones that had access to this password history file. And they do have access to this anyway as part of their daily job. And yeah, by forcing password resets, we prevented attackers from being able to exploit those passwords. And we took some other safeguards. Like, for example, if you think about this metadata that was attached to it, we tried hard to prevent re-identification attacks. And in this survey that we conducted, we did not include sensitive leaks, so adult websites, for example. Now to the most exciting part, let's have a look at the findings and the results. So we guessed around about 12,247 passwords based on password reuse, and this roughly accounts for 5% of the user base. This shows that password reuse is widespread. At the same time, it's not a huge number. However, the numbers change when you have a look at the exact email matches, right? So if I had mgolla@uchicago.edu related password, then in this case, we were able to guess around about 32% of the accounts. So 1/3 of the users were affected. That's quite a big number. In more detail, we found over 150,000 of the usernames in existing data leaks. As you remember, we got around about 228,000 usernames from the IT department, and 150 appeared in data leaks. Which allowed us to generate 1.5 billion password guesses, and more than 14,000 of them were correct, and this is mostly due to password reuse and some common passwords. And over 1/3 matched users' current passwords, meaning that those accounts could have been compromised at any time. And if you have a look at the list of contributing data breaches, you can see them here. This is the top list. And you see that the classics like LinkedIn and MySpace still haunt over a decade later. And the breach compilations, they vastly amplify the attack surface, right? Contributing to thousands of valid guesses. Now let's have a look at the numbers over time, the guesses that we were able to make over time. In this graph, you see the line goes up, the blue line goes up every time a user selects a password that we were able to guess, and it goes down if they change this password. The blue line represents password reuse, and the magenta line at the bottom of this graph is common passwords. And then we have two vertical lines. The vertical lines are changes to the university's password policy over time. And the first observation that we can make is that password reuse is a bigger problem than common passwords. Okay? At no time were common passwords above password reuse. And then, yeah, we see that there's a sharp drop round about late 2014, and this is where the university changed their password policy from a minimum length of 8 characters and increased this to a minimum length of 12 characters, and this changed the situation quite dramatically. Reused passwords can stay valid for a very long time, even after similar credentials appear in a data breach. This is an example from the LinkedIn data breach. They had 1,415 active UChicago accounts with similar credentials to this data breach, and it took over 7.5 years for this number to cut in half, right? So even after until 2022, where we did the measurement, where we did the study, there were more than 500 users still using their old LinkedIn password that has been breached. Mm-hmm. And then reuse passwords seem to stay stable for a very long time. We had a median of 6.2 years and a maximum of 19.8 years. Given that this file is 20 years, you can see where this is leading to. And another contributing factor to this might be that the overall number of password leaks is decreasing. I think it peaked around 2012 or 2016, but ever since, at least individual service breaches become less and less over time. Now there is this question, who is burdened more, right? Who is worse, in quotes? Is it the students or the faculty? The answer to this obviously is it depends on the password leak. Let's have a look at the students first. For them, it's the website Check, which is a homework help site. Yeah? And they reused their passwords that they were already using at Check. And for faculty, it's the other way around. The majority of the passwords that were reused there originated from the LinkedIn breach. Then I promised you this question, is it worth our time to crack hashes? And the answer to this is yes. But to be fair, all of the guesses, or many of the guesses, were already found in plain text somewhere anyway. So maybe you do not need to buy a new GPU. But if you want to buy a new GPU, you can use those numbers and convince your boss. And similarly, there was this question, we wondered, is there a one-by-one verbatim reuse, or is the reuse slightly modified? And there we see an equal split, right? We found that many passwords were verbatimly reused, but tweaking the password did yield almost as many guesses, and should definitely be done by us. And then finally, I'd like to draw your attention back to this homework help site check. On the 30th of September in 2019, the UChicago IT service was forced to reset 134 accounts because they have observed suspicious activity. And it turns out that every single one of those had used a password that was part of the check data breach. And this wasn't an isolated event or something like this, but we saw 29 instances where the IT department was forced to reset more than 10 accounts due to suspicious behavior, suspicious activity, and some of them you can see here in this table. And finally, there is some survey results. I just want to give you a quick look, a high-level takeaway from the survey. Many of the affected participants, affected victims, were unaware that their password appeared in a data breach. Some of them, it's even worse, did not even know that they had an account with this breached website. 44% said the password that we correctly guessed was also exactly reused at yet another website that was unrelated to UChicago. And when we asked about their perceptions, there were some participants, unfortunately, that reported not being comfortable with us doing this kind of study and sharing the passwords with the IT department. However, most were fine with the idea of periodically checking their credentials against a third-party compromised credential checking service, which I abbreviated C3 here in this graph. At the bottom of the slide, you can see this. So let us move on. What can we learn from such findings? What can I recommend doing? First and most importantly, what really broke UChicago's neck, you need to implement a process to expire unused accounts, right? Accounts that are no longer active, not longer being used, should be disabled, and you need to invent a process to re-enable them if they really need access after 10 years or whatever the time frame is. Secondly, you need to promptly check for high-risk breaches. This is, at the case of the university, this homework website check that contributed a lot to this. And you should implement continuous monitoring. I like to emphasize this continuous part. It's not a one and only set and forget check that you do when the password is being created. And then fourth, you should also check for tweaked and hashed credentials, which contributed a lot to ours, at least. And finally, please also do similar email address and username checks, and not only the exact email address matches. Okay, to summarize, password reuse is a bigger problem than common passwords. I think this is obvious to many here in this room, but in science we always need to have the evidence, and here is the evidence. In response to this, the University of Chicago has made two-factor authentication mandatory for faculty, staff, and students. We found that the accounts were vulnerable for many years. Unfortunately, this also means that the reactive checks failed because the password was older than the breach, right? And yeah, finally, we recommend that password reuse checks should be done during account creation or password creation and periodically be done afterward. And of course, it's very important to expire unused, inactive accounts. Have some offboarding process in your company. If you are curious to learn more, I can recommend this industry-friendly summary, which is a blog post with the key details, with the numbers that you need to convince your boss to buy a new GPU for you. And if you want all the details, then please have a look at the paper. Thank you very much.